We are going to start 11.1. Let me present my screen. Eleven point one deals with the sequences. Definition of a sequence. A sequence is a function whose domain is the set of natural numbers. So, a sequence is a function whose domain is the set of natural numbers. A sequence is usually represented by sequence an. You read it as sequence an. And n varies from 1 to infinity. N is equal to 1, 2, 3, 4, etc. Only natural numbers are permitted. And an represents the nth term of the sequence. Limit n approaches infinity an, that is the limit of the sequence, is equal to L, a finite number, means if n is a very, very large number, then the value of an is approximately equal to L. So this is not the mathematical definition. This is the layman's definition of the limit of a sequence. So this is the meaning, not the mathematical definition. Limit n approaches infinity, an is equal to L means if n is very, very, very large, then the value of an is approximately equal to L. If L is finite, then we say that an converges or sequence an is convergent. Otherwise, sequence an is divergent. So if limit is infinity or negative infinity, we say this is divergent. Example 1. You consider the sequence an is equal to 2n square plus 3 divided by n square plus 1. Your question is find limit of n as n approaches infinity. So what you do is limit n approaches infinity, an is equal to limit n approaches infinity 2n square plus 3 divided by n square plus 1. You divide both numerator and denominator by n square because n square is the highest degree term. So you get limit n approaches infinity, 2n square over n square is 2 plus 3 over n square divided by 1 plus 1 over n square. That is 2 plus 3 over infinity. You are replacing n by infinity. Infinity square is infinity. 2 plus 3 over infinity square divided by 1 plus 3 over infinity. But 3 over infinity is 0. And 1 over infinity also is 0. So this is not a 3, this is a 1. 1 over infinity square. Denominator is 1 plus 1 over infinity square. I'm sorry for that mistake. So that is equal to 2 plus 0 divided by 1 plus 0. 1 over infinity is 0, 3 over infinity is 0. So that is 2 over 1, which is equal to 2. Therefore, sequence an is convergent. The reason is this limit is a finite number. Example 2. Limit an is equal to 2n cubed plus 3 divided by n square plus 1. So here, limit n approaches infinity, an is equal to limit n approaches infinity, 2n cubed plus 3 divided by n square plus 1. As in the previous case, divide both sides by both numerator and denominator by n square. So you get limit n approaches infinity, 2n plus 3 over n square two n plus 3 over n square divided by 1 plus 1 over n square, that is equal to 2 times infinity plus 0, 3 over infinity is 0, divided by 1 plus 0, which is 2 times infinity, which is infinity. So that sequence is divergent. Now, there is a theorem. If limit x approaches infinity, fx is equal to L, then and fn is equal to an, then limit n approaches infinity, n is equal to L. So this is another way to find the limit. In order to find the limit, you know this is not differentiable, but fx is different. Fx, you may apply the L'Hopital's rule there, but you cannot apply the L'Hopital's rule in the case of a sequence. So for example, this one is not differentiable because that function is not continuous. So this is a technique where you can apply the L'Hopital's rule to find the limit. Okay, so next is Squeeze theorem. If an is less than or equal to Pn is less than or equal to Cn, and if limit n approaches infinity, an is equal to limit n approaches infinity, Cn is equal to L, that is limit of the first sequence is L, limit of the third sequence is L, so limit of the middle one also will be L. Limit n approaches infinity, Bn is equal to L. So the first question is, list the first 5 terms of the sequence. This is question number 6. An is equal to cosine n pi over 2. So A1 is cos 1 pi over 2. A2 is cos 2 pi over 2. A3 is cos 3 pi over 2. A4 is cos 4 pi over 2. A5 is cos 5 pi over 2. Now you find the values. You may use a unit circle or the calculator. Cos pi over 2 is 0. That is A1 is 0. Cos 2 pi over 2 is cos pi. That is negative 1. Cos 3 pi over 2 is 0. Cos 4 pi over 2 is 1. That is same as cos 0. Cos 5 pi over 2 is equal to, this is A5. Cos 5 pi over 2 is 0. Okay. Then H. An is equal to negative 1 to the power of n times n divided by n factorial plus 1. What is n factorial? N factorial is 1 times, 2 times, 3 times, etc. up to n. So A1 is negative 1 to the power of 1 times 1 divided by 1 factorial plus 1. Negative 1 to the power of 1 is negative 1. So that is negative 1 over 1 plus 1, which is negative 1 over 2. A2 is negative 1 the whole square, n is 2 times 2 divided by 2 factorial plus 1. So that is negative 1 the whole square is positive 1. So the numerator is 1 times 2 divided by 2 factorial is 1 times 2, which is 2. 2 plus 1, that is 3. So A2 is 2 over 3. A3, negative 1 whole to the 3 times 3 divided by 3 factorial plus 1. Negative 1 the whole cubed is a negative 1 times 3, that's a negative 3, divided by 3 factorial, that is 1 times 2 times 3, which is 6, plus 1, so it is negative 3 over 7. A4, negative 1 to the power of 4 times 4 divided by 4 factorial plus 1. Negative 1 to the power of 4 is a 1, so 1 times 4 is the numerator, so numerator is 4. 4 factorial is 24 because 1 times, 2 times, 3 times, 4 is 2 times 3 is 6, 6 times 4 is 24. 24 plus 1 is 25, so A4 is 4 over 25. A5, negative 1 to the power of 5. Here this number is not a 4, that number is a 5. Negative 1 to the power of 5 times 5 divided by 5 factorial plus 1. Negative 1 to the power of 5 is negative 1. Negative 1 times 5 is negative 5. Divided by 5 factorial is 1 times, 2 times, 3 times, 4 times 5, which is 120, plus 1, which is 121. So A5 is negative 5 over 121. And here is a recurrence formula. A1 is 6. An plus 1 is An divided by n. So A1 is given. A2, n, if you replace n by a 1, A1 plus 1, that is A2, is equal to A1 over 1. N is 1. So it is A1 over 1, that is 6 over 1, 6. A3, is a2 divided by 2. So that is 6 over 2, which is 3. a4 is a3 divided by 3, that is equal to a3 is 3. 3 divided by 3, that is 1. a5 is a4 divided by 4, that is 1 divided by 4, that is 1 over 4. Then find a formula for the nth term an. In some cases, these kind of questions are difficult, but you look at these problems. a1 is 4, a2 is negative 1, a3 is 1/4, a4 is negative 1/6. Now you think about a way to get a second term out of first and third term out of second. If you multiply the first term by a negative 1/4, you get negative 1. If you multiply that by another negative 1/4, you get 1/4. So the formula is negative 1 to the power of n plus 1, because first term is positive. Alternate negative and positive, there will be a negative 1 to the power of something. And that exponent is n plus 1 here, because we want to see that first term is positive. When you substitute n is equal to 1, it must be negative 1 to the power of 1 plus 1, negative 1 to the 2. So that is positive 1. So negative 1 to the power of n plus 1, 1 over 4 to the power of n minus 2. You simply substitute n is equal to 1. When you substitute n is equal to 1, what do you get? 1/4 times 1 minus 2. 1/4 times negative 1, which is 4. When you substitute n is equal to 2, 1/4 times 2 minus 2, that is 1/4 times 0, which is 1, but negative 1 to the 2 plus 1 is negative 1 to the 3, which is negative n is equal to 1, this is positive, n is equal to 2, this is 2 plus 1, that is 3. So it is going to be negative 1 and so on. So that's it. Then number 16. 5, 8, 11, 16. Excuse me. 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. So this is an arithmetic sequence with the first term is 5 and the common difference is 3. So formula for the nth term is a1 plus n minus 1 times d. You recall results from the algebra. So a1 plus n minus 1 times d, that is 5 plus n minus 1 times 3, that is 5 plus 3n minus 3, that is 3n plus 2. Now you may check your answer. When n is 1, 3 times 1 plus 2, which is 3 plus 2, 5. When n is 2, 3 times 2, 6 plus 2, that is 8. When n is 3, 3 3s are 9 plus 2, 11, and so on. Then number 18, you see the numbers are 1 and zeros. 1, 0, negative 1, 0, 1, 0, and so on. So cos, cos 0 is 1 and cos pi over 2 is 0. So answer is, sine pi over 2 is 1 and sine pi is 0. So you can use sine. An is equal to sine n pi over 2. N is 1 means sine pi over 2, which is 1. N is 2 means 2 pi over 2, which is sine pi, that is 0. N is 3 means 3 pi over 2. Sine 3 pi over 2 is negative 1, and so on. So that is the answer. Next, determine whether the sequence converges or diverges. If it converges, find the limit. We have worked out a similar question. So here, an is equal to 3 plus 5n square whole divided by 1 plus n. So limit n approaches an, n approaches infinity, not an. Limit n approaches infinity, an is equal to limit n approaches infinity, an is equal to limit n approaches infinity, 3 plus 5n squared divided by 1 plus n. Divide both sides, both numerator and denominator by n. So it becomes limit n approaches infinity 3 over n plus 5n divided by 1 over n plus 0. 3 over n infinity is 0. So it is 0 plus 5 times infinity divided by 0 plus 1. So this is 5 times infinity over 1. That is infinity. So that sequence diverges. Next. N is equal to 2 plus 0.86 whole to the power of n. So limit n approaches infinity. An is limit n approaches infinity 2 plus 0.86 whole to the power of n, and this part is 0. So if this b is between 0 and 1, then b to the power of n approaches 0. You have seen the exponential functions, because exponential function, the x-axis is a horizontal asymptote, and with the long run, that is as x approaches infinity, it becomes 0. So you can see this by graphing also. So you look at the graph by mode function 0.86 to the power of x, 0.86. Oh, clear. 0.86. See, it is coming closer and closer to the x-axis. That means in the long run, it approaches 0. So 0.86 to the power of n is 0. 0.86 to the power of infinity is 0. So it is 2 plus 0, which is 2. So it converges. Number 28, n is equal to 3 times square root of n divided by square root of n plus 2. So again, as in the previous cases, you divide both numerator and denominator by square root of n. So limit n approaches infinity, n is equal to limit n approaches infinity 3 square root of n divided by square root of n, all divided by square root of n plus 2 divided by square root of n. That is equal to limit n approaches infinity 3 divided by 1 plus 2 over square root of n. 2 over square root of infinity means 2 over infinity, which is 0. So that is 3 divided by 1 plus 0, which is 3. Next, an is equal to 4 to the power of n divided by 1 plus 9 to the power of n. Okay, so same technique we are applying. There are several ways to work out this problem. So I applied the same technique here. Limit n approaches infinity. An is equal to limit n approaches infinity 4 to the power of n divided by 1 plus 9 to the power of n. Divide numerator and denominator by 9 to the power of n, the bigger number. So that is numerator 4 over 9 to the power of n, denominator 1 over 9 to the power of n plus 1. 4 over n is a number between 0 and 1. So 4 over n to the power of infinity is 0. So it is 0 divided by 0 plus 1, because 1 over 9 also is a number between 0 and 1. So it is to the power of n. 1 over 9 to the power of n also is 0. So it is 0 divided by 0 plus 1, which is 0. Then n is equal to cos n pi over n plus 1. Limit n approaches infinity, an is equal to limit n approaches infinity cosine n pi over n plus 1. And divide numerator and denominator by n. So you get cos n approaches infinity, pi divided by 1 plus 1 over n. That is cosine pi divided by 1 plus 0, because 1 over infinity is 0. Cos pi over 1. So cos pi is negative 1. So the answer is negative 1. Number 34. N is equal to e to the power of 2n divided by n plus 2. And here again, apply the same technique. limit n approaches infinity, an is equal to limit n approaches infinity, you divide numerator and denominator of the exponent by n. So numerator becomes a 2, denominator becomes 1 plus 2 over n. 2 over infinity is 0. Therefore, this is e to the power of 2 over 1 plus 0, that is equal to e to the power of 2. Number 36, an is equal to negative 1 to the power of n plus 1 times n divided by n times square root of n. And in this case, I consider this in two different cases. N could be even or n could be odd. So case 1, n is even. If n is even, negative 1 to the power of n plus 1 is negative 1. So this is equal to negative 1 n, negative n divided by n plus square root of n. Divide numerator and denominator by n. So you get limit n approaches infinity, 1 over 1 plus 1 over square root of n. Square root of n divided by n is 1 over square root of n. That is negative 1 divided by 1 plus 1 over square root of infinity, which is 1 over infinity, that is 0. So that is negative 1 over 1 plus 0. Answer is negative 1. And case 2, n is odd. If n is odd, negative 1 to the power of n plus 1 is equal to 1. So limit n approaches infinity, an is equal to limit n approaches infinity, n over n plus square root of n. So divide both numerator and denominator by n, you get that is equal to limit n approaches infinity, 1 over 1 plus 1 over square root of n, that is 1 over 1 plus 1 over infinity. 1 over infinity is 0, so that is 1 divided by 1 plus 0, which is 1. So if n is odd, that goes to plus 1. If n is even, that is a minus 1. These two limits are not the same, so limit does not exist, and that means this is divergent. In fact, personally, I don't like the word divergent here. Actually, it is an oscillating sequence. We call it, the most appropriate term is oscillating sequence. But in your book, they say this is divergent, so I don't want to deviate much from the book. The reason why it is an oscillating sequence is, let us graph it. Replacing n by an x, you get negative 1 to the power of y is equal to negative 1 to the power of x times x over x plus x divided by x plus square root of x. Negative 1 to the power of n, n plus n divided by x plus square root of x. And let us say the graph. Let us try to change the window. Not the window, yeah. I don't know why the graph is not coming there. Window range. Why minimum? You are not getting any graph. Anyway, let's skip it. So this is the strategy here. You find the limit in two different cases. N is a natural number. N is a natural number means it is either even or odd. So when n is even, the limit is -1. When n is odd, the limit is +1. Therefore, these two numbers are not the same. So limit does not exist. It is in fact an oscillating sequence, but the book says divergent. So let us go with the book. Number 38. N is equal to natural log of n divided by natural log of 2n. You apply a property of natural log n, a logarithmic function. Logarithm of m times n is log m plus log n. So denominator is natural log of 2n, that is natural log of 2 plus natural log of n. And now you divide both all the terms by natural log of n. So numerator is 1 divided by natural log of 2 over natural log of n plus 1. So limit n approaches infinity, a n is equal to limit n approaches infinity 1 divided by natural log of 2 over natural log of n plus 1. Natural log of n is natural log of infinity is infinity. So natural log of 2 over natural log of infinity is natural log of 2 over infinity, which is 0. So this is 1 divided by 1, which is 1. Number 40. N is equal to tan inverse n divided by n. So we are going to use the squeeze theorem here. We know tan inverse n lies between negative pi over 2 and positive pi over 2 because natural log of, not natural log, the range of tan inverse x is negative pi over 2 to pi over 2. If you are not sure, you can graph it and see y is equal to second tan x over x, the second tan x. That is the graph. I'm going to change the window. So window negative, that's negative 10 is okay. Y negative 3 to 3. And again, I'm going to draw y is equal to pi over 2 and negative pi over 2. Negative pi over 2 and negative pi divided by 2 and then pi over 2. See the graphs. Here is negative pi over 2. Here is pi over 2. So the tan inverse function lies between negative pi over 2 and pi over 2. Okay, so we know negative pi over 2 less than nor equal to is there, less than tan inverse n less than pi over 2. Therefore, negative pi over 2 over n less than tan inverse n over n less than pi over 2 over n, that is negative 1 of pi negative pi over 2n less than an less than pi over 2n. And what is the limit of left side? Okay, limit of n approaches infinity negative pi over 2n less than limit n approaches infinity an less than limit approaches n approaches infinity pi over 2n, and that is 0 less than limit, because this is 0, that's negative pi over infinity, that is 0. Negative 0 is the same as 0. 0 less than limit n approaches infinity an less than 0. So limit lies between 0 and 0 means that limit must be equal to 0. So it is convergent. Okay, here next one is number 42. Natural log of n plus 1 minus natural log of n. Here again we use a property of logarithm. Natural log of m over n is natural log of m minus natural log of n. So here this is natural log of n plus 1 whole divided by n, that is n over n plus 1 over n, that is natural log of 1 plus 1 over n. And so limit n approaches infinity, an is equal to limit n approaches infinity, natural log of 1 plus 1 over n. 1 over infinity is 0, so that is going to be natural log of 1 plus 0. That is natural log of 1, which is 0. So that is the answer to that question. Yeah, you have a few more questions. It goes up to 52. Okay, so 46. N is equal to 2 to the power of negative n times cos n pi. So that is cos n pi divided by 2 to the power of n, because negative exponent means a reciprocal with positive exponent. We know cos n pi lies between negative 1 and 1, because minimum value of cosine function, I mean the range of cosine function is from negative 1 to 1, just like we have seen the tan function. So negative 1 less than or equal to cos n pi less than or equal to 1. And now divide all the 3 times by 2 to the n. That is negative 1 over 2 to the n less than or equal to cos n pi divided by 2 to the n less than or equal to 1 over 2 to the n. That is negative 1 over 2 to the n less than or equal to a n less than or equal to 1 over 2 to the n. So find the limit on all the 3 terms. Limit n approaches negative 1 over 2 to the power of n less than or equal to limit n approaches infinity a n less than or equal to limit n approaches infinity 1 over 2 times 2 to the power of n. 2 is greater than 1. So we know limit of b to the power of x is 0 if b lies between 0 and 1, and it is infinity if b is greater than 0, because the graph of y is equal to b to the x. You know how the graph looks like. B to the power of x, that is 2 to the power of x. Y is equal to 2 to the power of x. See the graph. It is going to infinity. So that means limit of 2 to the power of infinity is infinity. So this is negative 1 over infinity, and this is 1 over infinity. Both of them are 0. So 0 less than or equal to limit n approaches infinity a n is less than or equal to 0. And that means the limit of a n lies between 0 and 0. So the limit n approaches infinity a n is equal to 0. Number 48. N is equal to nth root of n. Nth root of n is n to the power of 1 over n. Now you find the natural log on both sides. So natural log of an is equal to 1 over n times natural log of n. That is natural log of n divided by n. Now we are going to apply a little calculus. So let fx is equal to natural log of x divided by x. This is natural log of n divided by n. Fx is natural log of x divided by x. You know the reason I already explained. You cannot differentiate natural log of n over n because that's not a continuous function. So we consider a continuous function, natural log of x over x, which behaves exactly similar to this. Now use the L'Hopital's rule here. Limit x approaches infinity, fx is limit x approaches infinity natural log of x over x, which is infinity over infinity. So apply the L'Hopital's rule. Derivative of the numerator is 1 over x, divided by 1. So this is 1 over infinity. 1 over infinity is 0. So limit n approaches infinity, natural log of an is 0. That means an is equal to e to the 0. Natural log, the base is e. So an is equal to e to the 0, which is 1. Number 50. An is equal to natural log of n the whole square divided by n. Let fx is equal to natural log of x the whole square over x. And same strategy as in the previous case. So limit x approaches infinity, fx is equal to limit x approaches infinity, natural log of x the whole square over x, that is infinity over infinity. And so apply the L'Hopital's rule. Derivative of the numerator is 2 times natural log of x times 1 over x. Derivative of the denominator is 1. Still it is infinity over infinity because natural log of infinity is infinity over infinity. So apply the L'Hopital's rule once again. Limit x approaches infinity, 2 times 1 over x, that's 2 over x, divided by derivative of x is 1. So it is 2 over x divided by 1, that is 2 over infinity, which is 0. Therefore, limit n approaches infinity, natural log of n, the whole square over n is 0. Number 52. And this is another special kind of question. You have to find the limit as n approaches infinity of an is n minus square root of n plus 1 times square root of n plus 3. Here I am changing my strategy. This is n plus 1 times n plus 3. N plus 1 times n plus 3 under radical sign. Foil it. You get n square plus 3n plus n plus 3. That is n minus square root of n square plus 4n plus 3. And in this case, what I recommend is you multiply numerator and denominator by the conjugate. Conjugate is obtained by changing the middle sign. So multiply numerator and denominator by n plus square root of n square plus 4n plus 3 divided by n plus same thing, n plus square root of n square plus 4n plus 3. So that is n square minus a minus b times a plus b is a square minus b square. So this is n square minus n square plus 4n plus 3 in parenthesis divided by n plus square root of n square plus 4n plus 3. You distribute that negative sign, you get n square cancels, you get a minus 4n minus 3. Numerator is minus 4n minus 3 divided by n plus square root of n square plus 4n plus 3. Divide numerator and denominator by n. You get numerator is negative 4 minus 3 over n. Here n over n is 1 and n outside the radical is the same as n square inside the radical because n is square root of n square. So this is square root of n square plus 4n plus 3 divided by square root of n square. So it is n square over n square 1, 4n over n square 4 over n, 3 over n square. And now substitute the limit. So limit n approaches infinity. An is equal to limit n approaches infinity, negative 4 minus 3 over n divided by 1 plus square root of 1 plus 4 over n plus 3 over n square. 3 over infinity is 0, 4 over infinity is 0, 3 over infinity square is 0. So the answer is negative 4 minus 0 divided by 1 plus square root of 1 plus 0 plus 0, that is negative 4 divided by 2. 1 plus square root of 1, that is 2. Negative 4 divided by 2 is negative 2, and that is the answer. So the answer in that case is negative 2. And that is the end of 11.1.